Alright, so let's take a look at question 3, which is essentially the same as question 2, but instead of a triangular network, we now have a square network. We know it's a square because it tells us it's a square, and it has the same areas as the area as the equilateral triangle of exercise 2. Okay, so recall that in exercise 2, we said that the side length A is a distance of A. So we said that the length of the base in that triangle in question 2 was A. The area of this triangle is going to be equal to 1 over 2 base height. Okay, and the base is A. We found the height from the previous, so we know this area, and we know that this is equal to the area for the square. So from here, knowing that this value, whatever this value AT is, it's equal to the side length squared, so then the side length is equal to the positive portion of the square root of AT. Why the positive portion? Because obviously I cannot have a negative distance, and not in any practical sense. So what is the length of the side of the square? We just solved that here. It's the area of the triangle. The area of the triangle, of course, being this value and then that value, which we saw in the previous video. If identical antennae are to be placed at the vertices of the squares, what's the minimum radius? Okay, well, I have a square. I know the side length, right? Well, if I want to know the point of the center of that square, I can draw this triangle and I can draw that triangle, right? And what's that point? Well, I mean, very obviously that's the midpoint here and the midpoint here, right? Because it's a square. You could either solve it from the triangles that you would construct, like you have this triangle that you're constructing, and then you also have, I'll use a different color, you also have this triangle that you're constructing. So your solution lies in those triangles. It's really not that tough of a problem, but essentially I can find this distance because I have this little triangle here. It's a square, ergo I know this must be 90 divided by 2 is 45. That must be the same angle, and so this must be 180 minus 90. Yeah, which I guess this is supposed to be a right angle, but does not look right angle. So, okay. But yeah, so this is supposed to be 90 degrees. It just doesn't look it because I didn't draw a good square. So, I mean, you have your answer in that. You find this side length. Again, this would be, you know, the sine of, I'll call this alpha, right? So sine of alpha over A equals the sine of beta over B. Alpha and beta are the same angles, so I guess this is the same thing as saying 1 over A is equal to 1 over B, because they will divide. And I guess that is exactly the same thing as saying that A is equal to B. So if I know one of those side lengths, once I have that one side length, let's say this side length, I know this side length and that side length. Okay, so no problem there. Now I do know this side length because this is S, and so sine 90, right, over S, sine beta over B. And we just showed that A and B are equal, so we have our answer. And that's the end of that question.